Right, boys, today we're going to have a look at rounding decimals. So the idea of rounding a decimal is that we're looking at some part of our number being significant and some part of our number being insignificant. Now what we mean by that is if I said to you that there were 18,564 people at the Waratahs game on Saturday night, if a newspaper was reporting on this, well, they might give the exact figure, and that's what we call the exact answer. Or they might say there was approximately 19,000. Or they might even say 18,500 at the game. So what they've said is that does it really matter when we're talking about 19,000 people whether we include these extra 64 people or not? Well, no, really it doesn't. So what we're saying is that it's some way of rounding that we're saying there wasn't exactly 18,500 at the game, but that's how many were approximately at the game. So if a newspaper were reporting on it, or you were talking to your friend about it because you'd been at the game, you might use one of these two numbers. But if they were counting exactly how many people were at the game, they would want to use this number here. Okay, now if we look at this idea as far as it applies to decimals, what we're saying is that if we have some decimal 0.7835, alright, well I could say that that is 0.784 to 3 decimal places, and that's just our notation there, that's all it means. And of course, how did I get that answer? Well, I got that answer by saying, well, let's stop and have a look. I stopped and got that answer because I said, well, if I'm looking to go to 3 decimal places, well, my first two here don't change. They are what they are. Well, but if I look at my next number, well, then I'm saying that's 35 there. Well, will that 35 be closer to 40 or 30? Well, our 35, if we are greater than or equal to 5, we go up. And if we are less than 5, we round down. Now that's not referring to the actual place that we're rounding to. You notice that our third decimal place there is a 3. That doesn't actually change how we round it. We look to the next place, okay? So we look to the next decimal place to work out whether we round up or we round down. Now, of course, here I've rounded that to 3 decimal places. If I wanted to round it to 2 decimal places, okay, well, we never go looking to this answer. We always come back to our original. Okay, so to round to 2 decimal places, I don't say, well, I round the 5 and then I round the 3 and we just look to our original answer. So that would be, well, of course, our 0.7 will get written down. Then I'm saying, well, 83, is that closer, is the 3 closer to, is the 83 closer to 80 or 90? Well, it's closer to 80, so it becomes 0.78, and that's 2 decimal places. If to keep rolling along, I could say it's, going back to my original, 0.8 to 1 decimal place. And again, what you see is that each time we round, we get a little bit less accurate. You notice here for our 0.8, we've cut off those little bits at the end. It's where we're becoming less accurate. Now, it doesn't really matter for this purpose because we've been asked to round it. And maybe it's like that example we talked about at the footy. Those other numbers after the decimal place, they don't matter as much. What if we have something, let's say I've got something like a 2.3018. All right, let's do it again. Let's say I'm going to round that to 2 decimal places. All right, well, of course, write down my 2, my point, and my 3. All right, well, now I look here. The 8 in this case has no impact on how I round. I don't say, oh, I'll round the 8 up and that becomes a 2. That's not how we do things. Just look at 0, 1, and of course, well, the 1 there is less than 5, so it rounds down, which means that my answer is just 2.30. Now, even though that last number there is a 0, we still must include it. If it says 2 decimal places, we must have 2 numbers after the decimal place. Doesn't matter whether it's a 0 or not. What about if I have something like this? Alright, well let's get this one to 1 decimal place. Okay, well again, this time, this one's actually going to come out a little bit interesting, so I'm not going to look here or here to decide how I round, I just look at those two. Well, actually what happens is my 9 rounds up to, my 9 is greater than 5 obviously, so then again my 89, is that closer to 80 or 90? It's closer to 90, my answer is 2.9 to 1 decimal place. Right, what if I've got something like this? 17.998, and I want to round that to 2 decimal places. Okay, what's going to happen here? Well, if we look at it, I'm going to look to this 3rd decimal place. That's where I decide to round. It's my 3rd place, so that's where I have a look. Well, that 8 is clearly bigger than 5, so it means we're going to round up. But then what will happen? Well, that 8 will make that 9 kick over to a 0, which will make that kick over. So my answer is actually 18.00. And again, what we'll see, 17.998, we're only 2 1,000ths away from 18 there. So we're only 2 1,000ths away from 18. So our answer there of 18.00, and again, it says 2 decimal places, so even though they're zeros, we still need to have them. We must use 2 decimal places. And again, we should put in brackets next to it. I'm running out of space here, but 2dp. That's just our notation. If we've rounded something, we should put in brackets next to it how many decimal places we've rounded to. So even though those are zeros, they still need to be there because it's to 2 decimal places. So even though it looks like we might have changed this answer a lot, we're actually very accurate here. Okay, thanks very much, boys.